we continue to look at the envelope of a one parameter family of curves. We've looked at examples where we had straight lines or linear functions, right? And we also looked at examples where we have quadratic functions. Now, we're not going to look at a specific example, no. We're going to do a little revision, because what we want to do is look at situations where the family of curves are circles, right? And this type of examples involving circles is the one that you're most likely to get to work out in an examination setting. No, we're not going to solve a specific problem here, but let's look at a little revision. What is a circle? Well, you can say it's a path that is traced out by a moving point when its distance, it maintains the same distance from a fixed point, all right? See if we can get a circle here. Right, so we have a circle there, all right? Now, here we have what is called our radius. Suppose we form an angle. We form a triangle here, all right? And this is our angle. Now, this remains our radius. We have our x, which runs from here to here, and our y, which runs from here to here, all right? By Pythagoras theorem, r squared is equal to x squared plus y squared. Remember your Pythagoras theorem, all right? We could also say x squared plus y squared is equal to r squared. Now, this is the general equation of a circle, all right? General equation of a circle. Oh, this was from our previous work. Now, if the circle is on a graph, let's say our xy plane and the circle here, then our center is the origin, 0. And we have our radius here, all right? Now you remember that if we go into the function and we subtract a number, the circle will slide to the right horizontally, and if we add a number to x, the circle will slide to the left. So suppose we have x squared, no, not x squared, x minus 1 squared plus y minus 1 squared equal a radius. So our radius is 1. We also have x minus 2 squared plus y minus 2 squared equal 1. We also have x minus 3 squared plus y minus 3 squared equal 1. Alright, so let's look at our graph and deal with these. Let's see what these look like. Alright. So let me type in the equation. X, alright, first equation, x raised to the power of 2. You can't see the equation I'm typing here, but I'm going to show you. theta plus y raised to the power of 2 equals 1. Alright, so let's zoom in. So we have this circle. X squared plus y squared is equal to 1. Let's make it blue and change the thickness. Alright. So this is our circle. Now, let me do a little thing here. Let me just copy and paste in here now. What I have is x minus 1 squared plus y minus 1 squared equal 1. Alright, so this is our new circle. X minus 1 squared plus y minus 1 squared equals 1. So both x and y move. Alright? We have changes in both x and y because I made both of them move. Alright? I want to see the function. Alright, so here we go. So you see that x move to the right one place to the right, y move one place up. So the center is now here. Right? Let me make some changes to this. Make it black. Or let me make the original function black. The original curve, the original circle. Suppose I change this to x minus 1 squared plus y alone squared. Y alone is squared. Only x moves. It moves to the right. Right? Suppose I make y minus 1 be the thing that is squared, while x alone is squared. Y was displaced one place upward while x didn't move. And of course, remember, if I make it such that instead of minus 1 is plus 1, it goes down here. And if I make x be the one that is translated, and I say it's plus 1, x plus 1, while there is no translation in y, moves to the left. And if I make both x and y be translated one place each, x plus 1, I should put it there. Alright, 1 to the left, 1 down. Alright, now suppose I go back to my original x minus 1 squared and y squared. This is what you see. Now I'm going to change the minus 1 to minus 2. Alright? And the minus 2 to minus 3. So, you see the general equation of a circle then would be x minus a squared plus y minus b squared equals 0. Or x plus a could be negative, squared plus y plus b squared equals 0. Alright? Anytime you see an equation looking like these, it's actually a circle. Alright? So, this is just a revision session. And as we will see later on, if we should find the envelope, we'll have to go through the same process as you have here. Alright? And then we actually work out everything and work it right down to find the envelope of the parameters of curves, in this case circles. So we'll look at the example in the next video.